So last Friday, we ended at trying to read the confidence interval for bootstrapping. And then I remember we went through this procedure where we did that in StatCrunch and we had the 2.5 percentile and what have you. And then I taught you how to read the 95% confidence interval. So I'll go over again. If you want to get a 95% confidence interval, we know that the whole area under this curve is 1. So if here is 0.95, we are left with 5%. We divide that 5. This is 0.95. The whole area is 1. So 1 minus 0.95. It gives us 0.05. We divide that by 2, and so it means this area here is 0.025. Here is also 0.025. And so to read the 95% confidence interval, we are going to look at the what? The 2.5 percentile. And then 0.25 plus 0.95 gives you 0.975. So 97.5 percentile. So that is how to read the bootstrapping confidence interval. So I wanted us to do an example. So I want you to open chapter 17, question 8, and then let's do that example. So this is my chapter 17 homework. And then this is the homework problem. So to attempt chapter 17, question 8, we are told that a business statistics class conducted a survey in which 299 students were randomly selected and a variety of questions and asked a variety of questions. And then when you read, we are told that the student drew 1,000 bootstrap samples and obtained the following histogram and statistics. So when you look at this one here, you have, this problem doesn't require you to go do bootstrapping and StatCrunch as we did the other time. Here, they have done everything for you and they have provided you with the summary statistic. And so this is the summary statistics, and they wanted you to find the 98% confidence interval. So to be able to get a 98% confidence interval, we draw the curve this way. We are looking for a 98% confidence interval. So here is for 0.9. Is that okay? What are we left with? We are left with 0.02. Is that okay? Because the total area is 1. So 1 minus 0.98 gives you 0.02. And then you divide this answer by 2, it means that here is going to be what? 0.01. And then here would also be what? 0.01. So to be able to read this, it means we need this 1 percentile and then 0.1 plus 0.98. So we need 0.01 or the 1 percentile and then what? The 99th percentile. Is that okay? So to read, we take the first one and then to get the other one, we add this plus this. You see that. Is that okay? So when you look at the table here, we need a 1 percentile. The 1 percentile is what? 730.6762. So we put in that. And then we need the 99th percentile, which is this one, 828.245. So that is how to be able to do that. Today, we are going to start from chapter 18. In chapter 18, we are going to talk about hypothesis testing. And so by the end of this class, you should be able to know what a null hypothesis is, what an alternative hypothesis is, how to formulate the hypothesis, and also know the steps involved in testing for the hypothesis. This section is in two parts. We are first going to start with proportions. So remember, we learned proportions in chapter 16. We are going to build on them. So same idea, but we are just going to apply hypothesis testing on that. Then the point is, why do we need hypothesis testing? Hypothesis testing helps us to make intelligent decisions. For example, if you placed an advert on Super Bowl, you'd want to test whether the advert you placed on Super Bowl really increased your sales. Does that make sense? So it helps us to be able to make informed decisions. And then for us to be able to do hypothesis testing, we are going to look at two hypotheses. One is called the null hypothesis. So I want you to write in your notes that the null hypothesis is always denoted by what? H subscript naught. So anytime you see H subscript naught, it's called the null hypothesis. And then the other one is the alternative hypothesis, which is also denoted by H subscript A, in some textbook A subscript 1. So the hypothesis testing, the idea it's like a court trial. So for the null hypothesis, it's like you are innocent until you are proven guilty. And then the alternative is what you are trying to prove, that something has changed or there is some effect. So the null hypothesis always assumes that nothing has changed. And then remember, I told you that what? We denote that by H subscript naught. So we usually write it in the form, the parameter, and then the hypothesized value. So you see, for example, we are talking about proportions. And so the hypothesis is always about the parameter, not the statistics. So it's always going, if it's proportion, it's always going to be P and not P hat. So hypothesis is always about the parameter. So for example, we could have H not equal, H naught is what? P equals what? 0.2. And then the idea is that there are some problems that is going to formulate the hypothesis for you. But most of the times you have to be able to read the problem, understand that, and also formulate the hypothesis. And remember, I said the null hypothesis always assumes that nothing has changed. So for example, you see it's what equal to here. Is that okay? That is for the null hypothesis. And remember, it is denoted by what? H naught. And then the alternative hypothesis is denoted by HA or H1. I think in this course it is HA, but I just wanted you to also know if you see H subscript 1, it means that it's also the alternative hypothesis. It is the same thing. So it is very important that when you see the symbol, you are able to identify that this is the null hypothesis and this is the alternative hypothesis. And then the alternative hypothesis is not a single value, but all other values of the parameter. So for example, remember here, the null hypothesis is what? P equals 0.2. The alternative could be greater than 0.2, less than 0.2, and what have you. And then I want you to also get this trick here. So for example, the alternative hypothesis, it could be one-sided and it also could be two-sided. It's two-sided if only here is not equal to. Is that okay? It's two-sided if here is what? Not equal to. Then it's a two-sided alternative hypothesis. It's one-sided if here is less than or here is what? Greater than. The null hypothesis can never be not equal to, can never be less than, can never be greater than. I repeat again. It's only the alternative hypothesis that you can get not equal to, less than, or greater than. The null hypothesis cannot have any of these symbols. Is that okay? Is that very clear? So for example, if you see H naught P 0.2, this is incorrect because this greater than is only for the alternative hypothesis. Is that very clear? If you see H naught P not equal to 0.4, this is incorrect because this is a null hypothesis. It can never be what? This. Is that okay? Remember, we learned that what? The null hypothesis what? Assumes what? A single value. And then, so if you also see maybe null hypothesis P is less than 0.8, this is incorrect. All these signs are for the what? Alternative hypothesis. So that is the one thing I want you to know. And I repeat again, if you see the alternative, say P is not equal to 0.5, because here is not equal to, this tells you that it's a what? Two-sided alternative hypothesis. Now, there are steps in testing the hypothesis for proportion. Remember, I've told you that the hypothesis testing is for only parameters and not statistics. So parameters are for population. Statistics are for sample. So hypothesis testing is about the what? The population. So I want you to know that. So for example, if you see H naught, P hat, we are interested. So if you want to write that, it should be H naught P and not P hat. The steps involved in testing for the hypothesis for proportion. The first step is what? We formulate the hypothesis. That is step 1. Step 2, we check the assumptions. We have already spoken about these assumptions in chapter 16 for proportion, and then for the sample mean, we spoke about them in chapter 17. So step 2 expects you to be able to check the assumptions. And then for proportion, after you formulate the hypothesis, you check the assumption. The next step is for you to compute the test statistic. So for the proportion, the statistic is given by this. So I want you to be able to write that down. StatCrunch also computes that for you, but I don't know the problems you are going to get, so probably you might also need to compute it manually. So it's very important that you have this written down. After we compute the test statistic, the next thing we want to compute is the p-value. For the p-value, we are going to use the StatCrunch to compute that. After we have done this, the next step is to be able to make a statistical conclusion, and then after we make the statistical conclusion, we would also make an English conclusion. So these are the 4 steps in hypothesis testing. What are the statistical conclusions? The statistical conclusion is in only 2 forms. Either we reject H naught or we fail to reject H naught. It's going to be only 2 ways. Either we reject H naught or we fail to reject H naught. So I want you to write that. And then to be able to arrive at the English conclusion, it's going to depend on what you decided on the statistical side. If we reject H naught, it means that then there is evidence. We are going to conclude the English later depending on the problem. If we fail to reject H naught, it means that there is not enough evidence or there is no evidence. I go over step 4 again. Step 4, we are going to make conclusions, and the conclusions are in 2 parts. Statistical conclusions and then also English conclusions. For statistical conclusions, it's in 2 parts. Either we reject H naught or we fail to reject H naught. These are the only 2 things we can do. And to be able to arrive at this conclusion, it's going to depend on the p-value. We will get there. And then for English conclusion, it depends on what happened at the statistical side. If we rejected H naught, it means that there is evidence. If we fail to reject H naught, it means that there is no evidence. So these are the steps involved in testing the hypothesis for proportion. Now we are going to look at example, and I am going to do this step by step. So I want to take Monday, Wednesday, today, Wednesday, and Friday to take time and then go through this topic because it's a bit tricky. Now we are going to learn how to formulate hypothesis. That is the step 1 of the hypothesis testing procedure. To be able to formulate the hypothesis, it is very important that you read the problem because we formulate the hypothesis from the problem. Is that okay? Good. So I'm going to give you 2 minutes to read this problem. Okay. The problem says that a large city's Department of Motor Vehicles, which is DMV, claimed that 80% of candidates passed driving tests. But a news reporter survey of 90 randomly selected local teams. So from here, you can see our N is 90. Okay, good. Who had taken the test found that only 61 passed. So our X is what? 61. That is the number of people who passed out of the 90. Is that okay? Are we all okay on that one? Okay. So just from here, we can see that our P hat is equal to what? 61 over 90. That is the proportion of people who passed. Are we all okay? It's P hat because it's based on the sample. Are we all okay on that? Okay. Now let's learn how to formulate the hypothesis. I just wanted you to know how to get some of the numbers there. So the question says that, does this finding suggest that the passing rate for teenagers is lower than the DMV reported? So since I see that here is lower than DMV reported, so to formulate this hypothesis, I'm going to get, so always to formulate, we start with the null hypothesis. So we write H naught and then HA. Is that okay? We write the null hypothesis first, followed by the alternative hypothesis. Is that okay? And then based on this problem here, it says that, does this finding suggest that the passing rate for teenagers is lower than the DMV reported? So P is less than, what did the DMV report? 80%, 0.8. Is that okay? If you get the alternative, the null is always easy. P is equal to 0.8. The hypothesis formulation is always about the parameter, not the proportion. So you don't have to put this value here. That will be what? Incorrect. Is that okay? This is P hat. The hypothesis is always about the what? The population or the parameter. So you see how I was able to formulate this hypothesis based on this problem. Now, let's learn how to formulate yours. So I want you to open to chapter 18, question 1. Take your time, read, and then we are going to discuss. You tell me what you think it is. It is okay for you to try and not get it wrong. That way you learn. Is that okay? So I want you to open to chapter 18, question 1. So looking at my problem on the screen, who would like to tell me what do you think the right answer is and why? Why do you think it's B, Carson? Yeah. So with this, it's very easy because they're asking you to tell the null hypothesis. Is that okay? And then we've already learned that the null hypothesis cannot be not equal to, cannot be less than, cannot be greater than. These are for the alternatives. Is that okay? So it's easier for you to see. In my situation here, the right answer is B. The next thing I want us to do is to go to question 6. So what do you think the first one should be? So in question 6, we are trying to answer A through C. So A expects us to be able to what? Write the null hypothesis and then the alternative. So when you click on this one, what do you think the right answer should be for the first one? Equals. Do you all agree with that? Okay. How about the alternative? Why do you think it's less than? Yes. So when you look at this, you can see from here that they are hoping to keep the negatives below 44%. Is that okay? That should give you the idea that it's what? It's less than. Let's get to B. What do you think they should be? Equals. How about the alternative? Not equals. Do you all agree with that?
I have a question. I assume not equals because like reading that, I don't really see how it makes sense to like have a greater than or less than. But like, what is the actual reason that it is not equals?
So that is one trick to like you also say, because if it's less than, it's going to be very clear for you to see like the ones you've done in the examples. But when you read that, when you look at this problem, it's just trying to ask you, is a section spinner fair? So it's like two,
Like yes
yeah,
no.
no,
Okay, that's what I thought.
yeah.
That's what I thought.
And then let's look at the last C. What do you think will be the null hypothesis? So here would be equals. How about the alternative? Why do you think it's greater than?
Because it's trying to be people who stop abusing alcohol or wait. I would think it was greater than because they want to like be more people succeeding. I don't know. My question I feel like made a little bit more sense on that section, so maybe I'm wrong.
That's okay. So when you read this problem, it says that only about 15% of people who try to stop abusing alcohol succeed. Okay? And then sellers of a motivational tip claim that listening to the recorded messages can help people succeed. So it says that let P be the proportion of people who try to stop abusing alcohol and succeed. So the sellers are saying that if you listen to their motivational speaker, their motivational tape or whatever it is, you are going to have more than 15% people succeed.
Okay.
Right? So here is going to be what? Greater than. Again, the alternative cannot be equal to. For example, the alternative you can't put equal to in the alternative. Is that okay? So even if you are getting something wrong, it shouldn't be like obvious mistakes. Do you get what I mean? Okay. So now that you have been able to learn how to formulate the hypothesis, now let's try a full example involving all the steps we have learned. So this was the solution for the first one. Okay, so let's now look at this example here. We are going to apply all the various steps we learned in the hypothesis procedure. It's the same problem. So we did the first one. So we formulated the hypothesis to be, we had H naught P equals 0.8, and then the alternative P is less than 0.8. Is that okay? Good. Now, step 2 says we should check the assumption. What is the assumption of the proportions we learned? The proportion assumptions we learned, one is independence. Is that okay? And then randomization. And then less than 10%. And then the success or failure assumption. Those are the 4 assumptions we learned about proportions in chapter 16. So we want to check the independence assumption. So, like when you read the problem, if the probability of you passing a DMV test, it's independent of somebody else writing and passing. So we can see that the independence assumption is satisfied, followed by randomization. And then we can see the problem even says it. The randomly selected local teams. Is that okay? So you can see that assumption is also.
How did you figure out that like the independence assumption is?
So I figured out independence because I know that if you go take DMV exam, it's your score, whatever you're going to do, it's independent of she taking the DMV exam.
Oh, okay.
So, and then our third one that we want to look at is 10%. So here they randomly selected 90 people. And so we know that that is definitely less than 10% because there are so many people who take the DMV exams. So that is also satisfied. The last one is we want to check. So we can see this is also less than 10% is also satisfied. The last one is the what? The success or failure. What is the success or failure? The success or failure says that what? Our P times what? This should be what? Greater than what? 10, and then N times Q should be also greater than what? 10. Is that okay? So here we have 80%. So we can see our P is 0.8. So 90 times 0.8, what does that give you? I think it's 72 or something. 90 times 0.8 gives us 72, isn't it? And then, yeah, 90 times. So we did NP to be 90 times 0.8, which is 72. We want to also check N times Q, which is also 90 times 0.2, which is also 18. So we can see that both of them are greater than 10 because the assumption says that both should be at least 10. And so we can see that this assumption has also been satisfied. Step 3 says that we should compute the standardized test statistic. So to compute that, we wrote the formula here. This is a standardized test statistic. So we already learned from here that our p hat is 61 divided by 90. What is 61 divided by 90?
About 68.
Yeah. So 0.678. I got 0.6777. So our p hat is what? 0.678. Now I want to write this formula there. So we have z equals p hat minus mu p hat divided by square root of p 1 minus p divided by n. Let me check. Yep, I think I wrote that right. So our p hat is what? 0.678 minus this mu p hat is always same as what? P, because we learned in chapter 16 that what? The mean of the proportion is always P. So that is 0.8. So this is going to be 0.8. Is that okay? Divided by our square root of P, 0.8, 1 minus 0.8, divided by our N. What is our N? Our N is 90. N is 90. So we got that.
Wait, so how is, on the top part, how is p hat 0.678? And it's
You-
also.
you mean this one?
0.8.
So this is p hat, which we computed it here, right?
Okay,
This is p hat.
yeah.
Is that
It's
okay?
gonna be the 61.
Yeah. So p hat, if you are not given, it's always the number of successes over n. Okay. And then in that situation, the number of successes, I think, was 61 or so. Yeah. So we had 61 over 90. Is that okay?
Yeah, so like where does is it mu?
Yeah. So this one here, this mu p hat here is the what? The mean of what? P hat. What is the mean of p hat? We learned that this, if all the assumptions are met, it follows the normal. The mean of p hat is always p. We learned this.
Oh,
So then you see this mean of p hat here is the same as what? Mean of p
I thought
hat.
it was saying like mu times. p hat.
No, so it's just like the
It-
mean.
So that, yeah,
Yeah.
that's more like.
Yeah. So I recommend that then if you think that, then try to write this way so that next time you don't get confused on that. Is that okay? So you can put mean of p hat there. And you know what some people also do? Some people also try to say, okay, well, let me simplify the formula. Some people also write z to be p hat minus p. That way they're always able to see that p is 0.8. Is that okay? Do you get what I mean? They could write it, for example, this same formula can be written as p hat minus p divided by square root of what? P, 1 minus p over n. And this is also correct. Is that okay? That way they're able to see p hat is this, p, then they come and look here and say, okay, well, p is 0.8, and then they just plug in, and then they get the answer for z. So now you have to just input this in your calculators. When you input into your calculators, what do you get for z? I got minus 2.893. So that is how to compute the standard test statistic. And then we are going to get the p-value from StatCrunch. And so to be able to make a decision. This is what I always tell my students to make stuff easier. So, for example, we have, so always try to know this, that if P is less than alpha, we what? We reject the null hypothesis. If this condition is true, we reject hypothesis. If alpha is a level of significance, if it's not given, most of the times, or if when you go in StatCrunch, it's automatically fixed there to be what? Alpha to be 0.05. Is that okay? So for example, if you get a p-value of, say, let's say a p-value is equal to 0.02, all you have to do is just do this 0.02 less than 0.05. Is this condition true? Yes. Is that okay? 0.02 is less than 0.05. If this is true, we what? We reject H naught. Is that okay? How about if a p-value is equal to, say, 0.13, 0.13, 0.05. Is this true? No. 0.13 is greater than what? 0.05. Is that okay? If you are confused, one thing I also say is that multiply by 100. You multiply by 100, you are going to get 13, you are going to get 5. So you can see this is not true. If this is not true, we what? We fail to reject H naught.
Where do we get the alpha from?
So the alpha, it's like assumed, it's like 95%. Yeah, 95% confident. When you go on StatCrunch, it shows there, it's 5%. Yeah. So let's try to learn how to do this in StatCrunch. So to be able to do this in StatCrunch, we go to stats, proportion, one sample, and then we go with summary. So to do this in StatCrunch, stats, proportion, one sample, and then with summary. Is that okay? So I click on that. What is the number of successes? In this example, when you look at our example, our number of successes is 61. Is that okay? The number of observations is 90. Is that okay? Now, you see, we have done this before. We came to look for the confidence interval here. But today, we are going to use the hypothesis test, so we maintain it here. Is that okay? In the hypothesis, we had P to be 0.8, so we change this 0.5 to 0.8. Is that okay? And then we change the alternative from not equal to less than. I go over again. So to be able to do the hypothesis testing in StatCrunch, we come to stats, go to proportion stats, one sample with summary. Our number of successes in this example is 61. Number of observations is 90. We are interested in hypothesis testing, and our P naught is 0.8. So we change this. This is ours is less than, so we change here too. And then you can see the significance it has given to you 0.05 already. So you just click on this and then click compute. So you see, this is the sample proportion, this is Z, this is also the critical value. And we're interested in the what? The p-value. I think we are behind time. So tomorrow we would proceed with the last step, which is what? How to make the decisions and then the conclusions.